Hello everyone! Last time I talked about wormhole. It's not theoretically impossible. But have you ever thought about how does it look like if you go inside a wormhole? If you look at the sci-fi show or sci-fi movie, then a lot of description is like going into a tunnel, but it's not like that. Today I'm going to show you how it actually looks like inside the wormhole.
Mysteries of the universe.
Last time I talked about a wormhole. If you haven't watched the video, please watch it. So it's like something like this. In Einstein's general relativity, strong gravity can bend the space-time. If you use gravity to bend the space-time like this, and then if you punch a hole from yellow side to blue side, then you can shortcut the travel. You don't need to go all the way straight, but you can do a shortcut, get to your destination. This is, in principle, how wormhole works. Have you thought about how does it look like if you really go inside wormhole? In a lot of sci-fi shows, it looks like this, like going through a beautiful rainbow tunnel. It's not like that. In another famous sci-fi show, you go into a tunnel with a lot of clocks. It's not like that. Today, I'm going to show in reality how it looks like. Are you ready? 3, 2, 1. This is how wormhole is going to look like. It looks like this. Around the center, there's a little bit blur white spot. That's the entrance of the wormhole. You see a density of stars is a little bit higher at the center. Why it looks like this? If you remember wormhole, something like this. Say if you look from the earth side, blue side, to the red side, at the exit of the red side, the space-time is bended like lens. All the light from the red side, in all angle from 0 degree to 100 degrees, the light is bended and then goes into the wormhole. All the lights from 100 degrees, 0 degrees, 90 degrees, all the light, because the space is curved, are going into the wormhole. This is very similar to the fisheye lens. If you use fisheye lens and then look up the sky, you are able to see the 360 degrees like in this picture. You see the horizon, right? That's because this fisheye lens gonna bend the light in all angles, and then bended light is gonna go into the detector camera. The wormhole, it's something like this. Just not the lens, but the gravity is going to bend the light. Let's go further in, and then going into the wormhole, closer and closer, and you see the central area is slightly brighter than other area because there all the light are corrected by the lens. There are more background light there, so it's a little bit brighter than the other area. Going in, and going in, and then out to the other side. So now other side is the normal universe. If you look back, you again see something like this. It's the same thing, right? This time you see the light from the back of you. Okay, this is how the wormhole in reality should look like. Today I'm going to do one more interesting topic, how to destroy a wormhole. It's actually very easy to destroy a wormhole. Last time I also talked about wormhole can be used as a time machine. If you remember like this, say you're going in from the yellow side and then going out from the blue side. If blue side of the wormhole exit is moving at a very high speed, then because of the special relativity of Einstein, the clock of the first moving side is going to tick more slowly than the yellow side. In this case, at the blue side, the clock is going to be slower than the yellow side. So, if you go in from the yellow side, where clock is ticking normally, and it goes out from the blue side, then because at the blue side, the clock is ticking more slowly, you go back in the past. So this is how wormhole can be used as a time machine. This opens interesting possibilities, but at the same time, taking advantage of this nature of wormhole, you can destroy the wormhole very easily. So this is famous Professor Stephen Hawking's idea. Say, if you shoot a laser from the Starship Enterprise at the center into the entrance of the wormhole, which is B, see, then the laser light went into B is going to show up from the A side of the wormhole, which is in the past. And then now you arrange a mirror to reflect the light again to the entrance B. But so that the laser from the past is going to interfere with laser from the Enterprise, so that laser is going to increase the intensity. You have to align wavelet of the laser so that it interfere and enhance the intensity of the laser. Then this enhanced laser is gonna go into the B again, and it comes up from A again and reflected the mirror and interfere with Enterprise laser again. So now immediately you created the infinite loop to enhance the laser, because the laser from the past is going to interfere with the laser you are shooting now, and then going into the past again, and it comes back and it enhances with you again. So this is an infinite loop. Then energy is going to be infinitely large. Infinite energy is going to be larger, and this large energy is going to collapse the wormhole. So wormhole can be easily destroyed, and this can happen in a very short time scale, as short as 10 to the minus 95 seconds. That's what Professor Hawking said. It seems very easy to destroy a wormhole. If we have an Olympic near a wormhole, it's very difficult it's a security nightmare to defend the wormhole, I believe. Okay, I talked about 2 topics today, and next time I'm going to talk about warp drive for the space travel. I kept saying I'm going to talk about warp drives, but I was preparing warp drive talk, and I noticed it's better to talk about wormhole first. But next time I really talk about warp engine. So please subscribe to my channel and then wait a little bit. As usual, if you like the video, please like it, and then see you next time. Live long and prosper, energize.